Alright, with problem number 4, the taxi cab driver charges a fare of $2 for the first quarter mile, and that's significant here, or less, and 75 cents for each quarter mile after that. So, if F represents the fare in dollars, which of the following equations models the fare in dollars for a ride m miles long, where m is a positive integer? Well, the difficult thing about this problem is that we're working with both quarter miles and whole miles. M, which is what the function is going to be defined in terms of, is miles. However, the charges are actually all done by the quarter mile. And so that's what's going to make this a little bit more complicated. Now you could start out by trying to figure out the equation and then checking your equation against the ones that are listed there. But it may be easier for you to check out what would happen for different values of m. And so m has to be a positive integer. Now I would suggest then that we look at what happens when m is equal to 1 and when m is equal to 2. So for example, at 1 mile, what should happen? Well, at 1 mile, you have the first quarter mile, and they should be charged $2 for that. Then you have 3 other quarter miles that they should be charged 75 cents for. So the total fee at 1 mile should be $2 plus 3 times 75 cents, which should be $2.25, so it should be $4.25. And it may just be enough just to test that one value. What happens at 1 mile? Alright, so let's see what happens. We're looking for a $4.25 value. Now if we use the first one, A, when m is equal to 1, you're only going to have $2. Because 1 minus 1 would give you 0. 0 times 75 cents would give you 0, plus $2 would be $2. So that is an undercharge there because it should be $2 for just the first quarter of a mile. They're missing the 3 75-cent charges. For the second one, m is equal to 1. So 1 divided by 4 is 1/4 minus 1. 1/4 minus 1 is negative 3/4. And negative 3/4 times 0.75, that's really negative 0.75 times 0.75. And that's going to give us some value, which I don't know what it is, but it's going to be a negative number. And so this second value is going to come out to be even less than $2. So the first one can't possibly be right, and the second one is even more of an undercharge than the first. Now the third one, m is equal to 1, so 4 times 1 is going to give you 4 minus 1 is 3. So that one has 3 75 cents, which is $2.25, plus $2, which is going to give you $4.25. For the fourth one, finally, what's going to happen at 1 is 1 minus 1 gives you 0. 4 times 0 is 0, and 0 times 75 cents. That one is also going to give you $2. So what we did in this particular problem was to try to figure out what the cost would be without a formula, and we should be able to do that for something very small like 1 mile. You could also do it for 2 miles as well. But m has to be a positive integer, so we couldn't do that for m equals 0. So we take our number 1 and we plug it in there, or we try to figure out based on the actual problem what the cost should be. We came up with $4.25, and then we plugged in that value into each of the formulas, and we came up with only one of them matching the value. And so C had to be the answer there. Only one of them gave us the $4.25 charge that we should have gotten. $2 for the first quarter mile, 75 cents for the second quarter mile, 75 cents for the third quarter mile, 75 cents for the fourth quarter mile, for a total of $4.25. And so that's probably the best way of going about this second one. Problem number 4.